nice. What a crowded room. Super excited. Thank you so much for being here. Today you are going to listen to my talk, Wired, and it's going to be about how your brain is learning new languages. So a little bit about the neurological side of it. How does your brain function? And then we're actually going to see how we can use that in our day-to-day practice. So you might wonder, who is she and why is she going to talk about specifically this topic? Well, I am Simone de Geit and I graduated in 2015 as a speech and language therapist and I finished my pre-master speech and language pathology. During those studies, you really focus on how is language coming to be, how do you learn it, does it evaluate, and all kinds of stuff related to the topic. But even though I really liked everything theoretical about it, I'm not really a therapist. I love solving puzzles, so I actually switched immediately after to IT, and I currently work for Open Value Amsterdam. But I thought it would be so nice to actually combine those two fields and see what's in it for you, and see what we can learn out of this. So what are we going to talk about? I thought about this setup where we could look over 10 comparisons between linguistics and tech. Well, those are the 10 that we're going to talk about. On the left side, you see all the technical stuff, and on the right side, you see all the linguistical stuff. And maybe there are some words that not really ring a bell, but don't worry about it, we get to it, and I will explain it more in depth when we get there. So let's start at the basics. Computer science. Probably a lot of you guys have had this course during your studies or maybe followed a course after your studies. And you might remember that computer science is the study about computers and computing. And one of the key concepts is that information can be represented as a sequence of zeros and ones. So on or off, 0 or 1, yes, true or false, you name it. So let's take an example in binary code. If we look at binary code, you can say that you have a few pillars, where the first pillar would be represented as 1, and that pillar can be on or off. Then from that point on, every pillar that follows that will be multiplied by 2. So you get pillar 1, pillar 2, then pillar 4, then pillar 8, 16, and so on. Now, in itself, one pillar cannot do tremendously lots of complex stuff, right? It can only be on or off. But if you put them all together, you can actually make a lot of different structures. So let's say somebody asks me, I now present those columns as light bulbs. Let's say someone asks me, Simone, please give me the number 1. I will believe, yes, yeah, I have a light bulb for that. Here you go, number 1. But then he's asking me, okay, cool, I'm very impressed. Can you now give me the number 3? And I will be like, oh, damn, I don't have the number 3. But fortunately, I can light the bulb 2, and then 1 plus 2 becomes 3, right? And so on and so on. So for example, if somebody asks me 6, I light 4 and 2, and so on. You can imagine, like, if you add more light bulbs to it, you can get more complex structures. Well, let's see how that compares to neuroscience. Neuroscience is a study about the brain. And as with the lightning bulbs, we have stuff like that in our brain. They are called neurons. Neurons are the cells that receive, process, and transmit information from one cell to the other. But just like the light bulbs, they only have 2 settings, on or off. But because an average adult person has about 68 billion, that is 9 zeros, from those neurons, you can imagine the complexity and the structures that you can make with that. So that's already quite nice, right? But how can we actually use it to learn? Well, there comes in the comparison between artificial intelligence and neuroplasticity. Funny fact, artificial intelligence is actually the simulation of human intelligence processes by machines. So it's actually based on your brain. So let's see how your brain works then. We've got something that's called neuroplasticity. Neuroplasticity is the nervous system potential for change. It's like a training mechanism. So if we look at artificial intelligence, let's take the example of you wanting to train the computer to recognize a picture of a palm tree. You present the computer with 100 different pictures, where a few of them are palm trees. Then the computer can say if it's a palm tree, yes or no. And after that, you give it feedback. Every time the computer chose a wrong picture, you will eliminate those processes. You will say, okay, no, that was the wrong outcome. We're not going to build further on that particular process. But if the computer actually picked a picture of a palm tree, you complement it and you say, okay, let's go from that point on, let's build upon that. That's a little bit the same with neuroplasticity. You are making pathways where you can stabilize the changes that you are creating. And every time you give feedback to your body, to your system, it will do something with that feedback. So for example, as a kid, you're trying to read, and the only thing you can do is focus and read, because every other impulse will like get you distracted and will definitely not help you in reading the text you are having at hand. But maybe when you're growing up, you actually want to read that newspaper and drink that cup of coffee. So you need to integrate it. And maybe the very first time you drink that cup of coffee during your reading your newspaper, you actually hit over the coffee, it spills your newspaper, it ruins your suit or your sweatshirt or whatever you're wearing. And you actually get some feedback like, oh man, no, this was definitely not the way to do it. So the next time you will be more aware. You will be more aware of your motor functions, of your surroundings, of everything you need to cooperate. Funny fact, neuroplasticity does get used up when you grow older. So it is a little bit harder to learn new stuff when you get older. It's like building a highway. If you got a highway, you cannot just build a highway on top of that, right? Because like car crashes will happen for sure. So it's a little bit harder, but don't worry. I was in my internship and I met a woman of 70 which had a brain infarct, and she could not talk anymore in the way that we are used to talk. And she was able to use her neuroplasticity, make new pathways, and learn it in a different way with pictures and with touch, stuff like that. You will be able, even if you're in your 70s, to make new pathways. It just gets a little bit harder. So don't be hard on yourself. It's very normal. Then third one, memory storage versus cognitive loading. Well, maybe you have heard that in our computers we have like two kinds of memory storage. We have long-term and we have short-term. Short-term can be, for example, RAM, random access memory, and long-term will be a non-volatile memory storage like a hard disk. Difference between them, if you cut the RAM off of the power source, it will lose all information that's on there, whereas if you cut off the power of the hard disk, actually when you reboot it, it will still be there. Beautiful. With every memory storage is a limited amount of information that you can store on there. That makes sense, right? We know that, otherwise we get like Stack Overflow and stuff like that. So we only have limited access to that. And that's a little bit like what's happening in our brain with cognitive loading. We have there as well a working memory, but cognitive loading is the amount of information that your working memory can hold at one moment in time. So for an average person, this is about 5 to 9. About 5 to 9 new items you can hold at one moment in time. Now let's see at the memory storage in our brains. As you can see, we have one extra. We have a sensory memory storage, which is about everything I feel but I don't feel or notice, but I don't pay attention to. So for example, I can see my fingers wiggling here, and I can see the people over there sitting on the side corners, but most of the time, I will not really see them. They will not really get into my working memory. The same as I can feel my feet on this stage, but most of the time I don't feel them. But it will still be inputted in my brain, I just never pay attention to it. But if I pay attention to it, then it gets into my working memory. There you have that cognitive loading. But luckily for us, we also have long memory storage. And every time you hear something that's already in your long memory storage, you can actually retrieve it from there. So those 5 to 9 items are about new items. Everything you already know is not needing to be obtained over here. It will also make it easier if you can place it into context. So if you maybe hear a new word, maybe the word tiger is completely new to me. I never heard of a tiger before. So it will be part of my working memory because I cannot retrieve it from long term. But then somebody explains to me, oh, a tiger lives in a zoo or in a jungle. And those are words I have heard before. I have been in a zoo. So it will be more easy for me to place the tiger that's in my working memory in my long-term memory. I do need to repeat it, but the times I need to repeat it are less high than I would if I have no context at all, and I need to learn it from scratch. Makes sense, right? So then let's see how we actually save the data in our brain. Let's look at domain-driven design. Domain-driven design has as a goal to have a model which can easily deal with new implementations and changes. And to facilitate that, they use bounded contexts, in which one model can exist in 2 different contexts and one inherits from the other. Now, in this example, you can see 2 contexts with a common model customer. Well, maybe the order management context has a customer with a name, an address, and a date of birth. Then the financial context actually inherits from that and adds 2 more to it, the IBAN number and an identification number. It goes a little bit the same in the brain. If I have the tiger example again, the tiger is new to me, so I need to learn stuff about that tiger. I need to learn that it is in a jungle, that it is like a cat-like creature, it is orange with black. And as I said, this will be way easier if I can place it into context, if I already know stuff about that. It will be even easier if I already have some different contexts about animals, where animal would be the highest one, but then I get like birds, mammals, fish, and so on and so on. You can already see it's like categorizing together with a mind map. And that is how you are tangling everything together. All right, the motherboard versus the brain. Who has ever built a motherboard? Okay, yeah, some. Cool, awesome. I'm very proud of you. I never did it. So don't ask me after this talk anything about how to build a motherboard. But I'm very impressed with the people who do, because I've heard that's a very detailed task. It really comes down to really implementing all the little stuff which have their own function, but they come together in a very specific way, right? You cannot really mess it up. Well, we have something like that, which is called our brain. We have here different lobes. There are 4 of them: frontal, temporal, occipital, and parietal. And most of them have different functions. They all kind of work together, but they have some focus areas. The frontal one would mainly be for executive functions. It would be about planning, about memory, attention, but also motoric functions. And, for example, the motoric function of the speech. That's actually in this area. It's very important to decide how you are going to pronounce certain words, but also the grammar rules are over here. Then we have occipital, which is about vision. And it's mainly about the interpretation of vision. So if I see a chair, then I would know, oh, that is something I need to sit on. So I interpret the thing I'm seeing. Then parietal, different to pronounce, is about cognitive and sensory integration. So everything I can feel and therefore give meaning to. Something that's happening over there will be writing, for example. I use cognitive information that I already have, and I use my sensory ability to actually write it down. And then last but not least, I think one of the most important areas for this talk will be the temporal lobe. It is very close to the ear, and therefore it is, or that's a good mnemonic, it is mainly for auditory functions. But it's also about giving meaning to words, about interpreting stuff, about processing, giving meaning to language, and about reading. It's mainly focused in this area. So with all this knowledge, this was quite theoretical, right? So how can we actually use this in our day-to-day practice? Well, the next slides will mainly be about how we can actually use this. All right, language versus programming language. In linguistics, we build everything up based on 3 topics: phonology, semantics, and syntax and morphology. First one, phonology, is about the sounds that separate a word from a meaning. So for example, if I say to you guys the word see, then maybe half of the room would think that I'm talking about the verb seeing. And maybe the other half would think I was talking about the blue wide ocean. Well, I'm not a native English speaker, so for me, see and see are the same. But maybe if you are a native English speaker, you could actually make like this very small difference in sound, whereby another native English speaker would maybe hear the difference. So that is about phonology, and it's also about placing it into context. So if I would say the sentence to you guys, I see a sea, then suddenly you would get it, because then you know like the context in which the word is occurring. But because this is not really applicable to IT, I just leave it at that. It's fun to know, but like you can forget about it. Semantics, yes. Okay, semantics, here we come already in an area where we can actually do something with the knowledge. Semantics is about giving meaning to words, about your vocabulary, and about categorizing stuff. So for example, if I think of the word looping in my mind, I will have an explanation of that. Well, looping is a function which has a condition, and it goes over that function until the condition goes to true. Now, that is semantics. And the fact that I can categorize it, say, okay, a looping, well, different kinds of loopings are a while looping, a do-while looping, and a for looping, that would help me place it into broader context. Then the syntax and the morphologic would be more about grammar, about your sentence structure, about the shaping of words. So if we take that while example again, and we look to sentence structure, we have agreed with each other that the sentence structure of a while loop starts with while, then is followed by a condition within parentheses, and then you get some statements within curly brackets. Now, this is actually something that is forced upon us quite brutal, right? Like the compiler will just say no to you. If you do it any other way, they will just say, not going to do it. So this one is not too tricky because we have tools in place, or we have a compiler in place, which will really learn us how to do it. But with the other two, it gets a little bit more tricky. So, for example, grammar, is something that humans make up. For example, a grammar rule could be that you never write a class name in plural. But that's something that we agree upon, and probably it's written down somewhere, but it's kind of hard to really force it, or at least most linters don't. And the same goes for the shaping of words. Well, naming conventions are always a struggle, right? I see it in every company again and again. It's so hard to really agree upon a normalized way in which you are writing your code. So one of the shaping of words rules could be that you always start a function name with a verb, for example. Well, this is all nice and dandy, but how are we actually going to learn this? Well, I needed to have like a comparison about something to learn, so I just placed these two here. So we have Codecademy, one of the learning platforms for IT, right? And Duolingo, one of the learning platforms for spoken languages here. And in this comparison, we're really going to look on how you are learning a new language. To do that, let's go back to our childhood, shall we? Huh? When everything was still nice and then the grass was still green, stuff like that. When we were a child, how did we learn a new language? Well, probably you didn't really notice, right? But now that we look back on it, and maybe you have kids of your own, you will recognize that most kids learn by parroting other people. They will start with easy words and the words they hear most often. So probably if you are someone who really loves a refrigerator, so you're saying the word refrigerator just as often as the word mum, then your child will still go for the word mum because it's just way easier than refrigerator, right? So that's how they kind of decide. They go for the easiest one and the one they hear most. And they are trying it out in different situations, trying to get feedback. Again, a little bit like AI. They just try it out and see if they get any feedback from the mom or from maybe sensory input, maybe like they got a wound or something. That's also quite a drastic feedback system. So how do we do this in IT? Well, most of you guys will have heard of Stack Overflow, I guess, right? I think almost everybody uses it, but be careful. Copy-pasting is not parroting. You are not learning a single thing if you're copy-pasting it. Learning is about really getting input, getting it in your working memory, so you need to pay attention to it. You're just not wanting to blindly copy-paste it. You need to pay attention to it. You want to place it into context, so you want to get like multiple different ways of input. And then by repeating that, you're going to save it in your long-term memory. So for example, with Stack Overflow, try to really read it, try to see if you really get it, and then, hold it, you're going to type it out. You're not going to copy-paste it, because then you actually will get another sensory input. So you have read it via your eyes, and then you're also typing it out again via your fingers, which are already two pathways leading to the same kind of information, which will make it way more easier the next time if you want to recall that same kind of information. But be careful for bad exams, because if you're a parent, you might know that when your child has learned something which was faulty, it's quite hard to unlearn. So for example, in linguistics, we also say to parents that really want to educate their kid also like Dutch and English, we really ask them, do you really know the grammar rules? Because if you're going to teach your kid English without knowing the actual rules, it will be very hard for your kid to later unlearn the mistakes that you've learned them. So that's a little bit the same as with Stack Overflow, right? You really need to know, are you learning the right thing? So try, if the examples are available, to always read through 3 solutions, 3 different URLs. See what kind of responses they got, see if you actually, if they are similar or are they completely different, and then base your conclusion based on that. So be careful. And oh yeah, try it out in different situations. Be like the kid. Be like if you're very new to Java and you want to learn about classes, try to learn, if you know the basic concept of a class, try it out in different situations. Can you use a static class? Can you use a final class, nested class, and so on and so on. All right. Then how to learn or improve your vocabulary. Because also in IT, we have quite a lot of terms, right? And it's kind of handy to know about those terms and about the functionalities that are implementing with those terms. So the upcoming the upcoming steps will be something that we actually tell people who are also learning spoken languages. So it doesn't really differ between IT and spoken languages. So what I would recommend is a daily or a weekly schedule where you place 30 minutes of focus time. You will, during those 30 minutes, you will take a maximum of 5 topics, not more. And I would only say take 5 topics if you're really comfortable already in that area. So if you already know a lot about the context wherein the new topics are occurring, then you can take a little bit more. But if you're new to the topic and you don't have a lot of context to place it in, please stick to 1. Then during those 30 minutes, you will read about it, you will write it down. There we go again. It's like making a summary during university. You're writing it down. You're trying to visualize it. I know this kind of may sound a little bit dumb, but this will actually help you. If you're visualizing it, you will call upon a different area in your brain, and it will actually make it more easy to recall it again. So for example, if I want to learn about records, which got introduced in Java 15, I think, then I know that it's an immutable data class, but I want to have a visualization of that. So I might think of a music record where there are songs on there and I cannot override them. Like the songs are on there, but I can get them and I can listen to them. So I have that picture in my mind, and then the next time someone asks me like, oh, what was records about? I will recall that image, and I can more easily tell the explanation of the actual word. And yeah, associate again. So as I already mentioned a few times, try to place it in perspective again. Try to see, okay, what are the different topics I can actually use records in? What kind of use cases do I have? Then the next week, you're actually going to use them. Most of the time, if you are aware of it, you can use this in your day-to-day job. I think most assignments will be flexible enough to get you to implement the topics that you've learned about. But if that's really not the case, if you're really unable to use your topic in your day-to-day practice, then please try it out in your home project or anything that you're building on at the moment. And after a week, when you're trying to learn a new topic, before that, evaluate it, see if you got actually new use cases which you haven't thought of before, so you can add that to your mind map, so to say. And if you really want to trigger yourself, go and explain it to others. Because that's just the most efficient way to really train yourself on the information and also get the satisfaction that you actually know what you're talking about. So it's like it's for both ways. You will inspire your colleagues and you will actually get the satisfaction of having learned something new and be able to share that with people. So maybe we finally get an agenda for those knowledge sessions that always got cancelled. Yeah? Nobody can that? Oh, okay. It's just me. Okay. Then how to improve your syntax or your grammar skills. So this is a little bit, the first thing is write down mnemonics. It's a little bit the same as the visualization, right? But then with mnemonics in Dutch is ezelsbruggetjes. might not all the people know. Write down something that you can trigger at the moment that you're like, oh, this was on the tip of my tongue. I kind of know what this is about, but I just cannot reach it. Then you go to or that visualization or to that mnemonic. Well, the different scenarios we already talked about, and you have something which is called creative contextual association, which is, again, connecting a symbol to a grammatic rule. So let's, again, see the records. The semantic meaning is a data class with immutable data. And then there's a grammar rule. I have, okay, it already implements a constructor, a getter, an equals function, a hash code function, and a toString function. Amazing. But I need to remember that. So I place it, I tangle to that, I tangle a symbol. And the symbol will be an equal sign with an arrow, which together makes a fat arrow, actually. So the fat arrow for me stands for getter, and the equal sign will help me remember that, oh yeah, with records, I don't need to implement an equals function because I actually already get it. Brilliant. All right, then how to prevent different languages from mixing up. Well, nowadays we hear more and more people wanting us to learn multiple languages, right? Full stack is very popular nowadays, or at least with the recruiters. No, it's great, it's great, it's great. But so you kind of want something that you can, yeah, prevent it from mixing up. It's just like what it says over there. So how to do that? First, try to avoid context switching. It's like you're going to Germany. Well, let me take myself as an example. I can speak quite a word German. I'm not too bad at it. But the very first day I will go to Germany, I will be quite rusty. I will be looking for words. I will be like, ja, ich weiß das. Ja, 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 ja. But I just don't really get to the words. Then the second day, it already goes a little bit smoother. And then the third day, I'm on fire. I can just talk German like a native speaker. Not really, but at least I feel very confident, and I can order my coffee and my bread. But in those 3 days, I didn't really learn a new word. I just dusted off my knowledge about German. It's like having that pathway, so the neuroplasticity that was used for me to learn German. It's there, I have a pathway over there, but branches grew over it because I didn't really maintain it. This is a little bit the same as with having to switch contexts. If you are working on Java and Kotlin and JavaScript at the very same day and every 2 hours you're kind of switching, then you keep on cutting away all those branches that overgrew your highway or your pathway. So you want to actually stay, or you don't have to do anything, but just here to help you guys. But I would recommend to stick to one language at least 1 day. Of course, it's more beneficial if you take it for longer periods of time, try to really block it out. But it will help you at least to do it 1 day, one language. Next to that, you can try to visualize the use of language. Again, that visualization. Last year, I got assigned to a new project, and that project worked with Kotlin. Before that, I was a Java developer, or still am, but at my current job, I do Kotlin. So there are a lot of similarities, and it was hard for me to distinguish them. Where comes one in, where comes the other in? So I tried to place this model in my mind. I placed 2 rounds, 2 circles, which overlap, and I quite literally place some words which are correlating in different circles. So for example, the records will be in my Java circle, whereas the data classes will be in my Kotlin circle. And then streams are something that are present in both of the languages. So by having this visualization, it's way easier for me to, if I want to write a data class in one of the languages, to know if I need to use records or data classes. Funny fact, the more languages you learn, the easier it is to learn a new language. So how many of you guys already speak more than one language? Hardly the entire room will be raising their hands, right? Okay, good. Good for you. At least then already you've learned how you are learning a new language. And by training those executive functions, by training how you are learning a new language, it will be more easy for you in the future to learn a new language. Next to that, you can imagine that you have more context. And maybe if you learn, well, if I'm going to learn Spanish, and I already know some French, I can kind of place mnemonics or hooks from one language to the other. Then you kind of do need to prevent it from mixing up again, right? So it has some advantages, but it also has some real need for separation. But it can be very nice, and at least, as already written down in my abstract a little bit, we can determine that we are linguistics, all of us, a little bit, especially because we're programmers. And we're actually, so everybody should learn, has like 2 languages, because you have your spoken languages and you have your written programming languages, which is already 2, right? So we're kind of brilliant, but we already knew that, right? All right, supportive colleague versus kindergarten teacher. Well, we all know how important that kindergarten teacher is, right? That lovely man or woman who is just like there when you cry or there when you feel, and she's just like stimulating and trying to say like, do it, you can do it, you are great. Well, try to be that for your colleague. So always try to positively correct it. To try to motivate him to keep trying and do it again and again. You can do that, for example, by the parroting mechanism. So in linguistics, we say if a kid says, me wanting apple, we recommend parents to repeat that same sentence in the right structure and adding an extra word to it. So if a kid would say, me wanting apple, the mother could say, oh, I want a tasty apple too. So then the kid actually, without getting like, oh no, you were wrong, you should have said, they actually get feedback and learned a new word along the process. Now, in IT, we have John. And John has implemented a for loop, which is correct. Like, I didn't make a mistake in that, I hope. Or at least, otherwise you can tell me after the PowerPoint. But John did a great job. He made a for loop. Whoo! He's there. But Barbara actually thinks like, okay, he could do this a little bit better or cleaner, more readable, stuff like that. So then you have 2 approaches. You can give direct feedback. You can add it in a merge request and say like, hey, John, did you think about this? Or you can give indirect feedback. So Barbara could think, okay, well, I'm currently working on a merge request, and that also implements a for loop in my way. I will ask John next time to review my code so he can see what I did over there. And then get some indirect feedback. So what you can do, some very general things, pair programming. We kind of all heard of it, right? But it's so nice. It's really, really helpful, especially when you're that positive, motivating kindergarten teacher, then pair programming is the best. A reviewer role is also great. Place things in broader perspective. So if you're seeing something in a merge request, maybe of yourself or maybe of your colleague, try to place it in broader perspective. Where can we also use this? Is this something we want to use in that other project as well? Stuff like that. But the biggest and most important thing is to talk about it. And not only about your merge requests, which is kind of nice, like don't only put comments in a merge request, but if you're really giving direct feedback, it's also kind of nice to call someone and really elaborate on why you gave that feedback. But it's also important to talk about how you want to receive feedback and how you're actually learning. Because we have 3 people over here. We have Mr. Handyman, and Mr. Handyman just wants to dive right in. He's like, I can do it, I will just go for it, and whenever I stumble upon something, I will go to Stack Overflow and I will get it done. That is Mr. Handyman. But we also have a Mr. Wise Guy, and Mr. Wise Guy is just very precise. He loves to read first through the whole Java manual. He wants to read through all the theoretical implications of it before actually starting. And then we have Mrs. Magnifying Glass, and she loves to first watch an example and then after that try it out herself. Well, if you've got a handyman and a Mr. Wise Guy in one team, then you're not learning it the same way. And that's not wrong. You're all very valid in your own way of learning. But if you don't talk about it, you can get very frustrated quite easily, both parties. So try to see and understand, okay, how do you learn? And how would you like me to give feedback? What would benefit you? And last but not least, try to talk about new techniques, articles, and blogs. Try to inspire each other, or what we talked about before, to see if you actually learned something good enough or well enough to actually elaborate it to others. Then the 9th, readable code versus doctor handwriting. Well, we all know some doctor handwriting, right? It's unbearable. We have no clue what's written over there. We kind of also have that if we sometimes open up projects of other people, right? It's like, oh my, it's going to take me an entire day to get through this code before I'm actually able to understand what's going on over here. That mainly has to do with patterns and agreements. So patterns lean on consistency, we all know that, but it's kind of hard to really do something with that. Luckily, we have tools which can help. Try to use them. But if you're not using tools, you can think of on which level am I making agreements? Am I using universal agreements? So agreements that are widely accepted in the whole community. Am I using company agreements? And if so, are they really easily or wisely documented, and can I easily find them again? And last, really last, team agreements. But try to stay out of that, like not like social-wise, but on like coding-wise and patterns and stuff like that. Because if you're making team agreements, then you kind of already know that when you get a new teammate, you need to first go through all that information before you can actually start working on the project. And most likely, you will not do that, and most likely, your project will become a mess. So I know it's sometimes hard with merge requests to give feedback on stuff that's written on this page, because you're like, it works, and I don't want to be a nitpicker, and I don't want to be that colleague that's like, oh no, yeah, please make another commit to fix it. But this can actually benefit you very much in a year. So again, talk about it beforehand, make an agreement that you guys are all going to do that, and then it will not be personal when you're giving feedback on those kind of stuff. Then last but not least, the little nerds versus the little linguistics. Well, we've got this little fellow over here, 0 to 4. Can we already start learning them something IT-wise? Well, don't do it. Just don't do it. They just like arrived at this world, and they're just still so innocent. Like, don't do it. But yeah, yeah. But when they are 4, they're already a little bit screwed up. No, they are already a little bit further in this world, and then you can actually already go ahead and teach them some of the principles, but you don't let them touch a computer, or like you can. But the IT principles I would not do by a computer, but by day-to-day practices. If you want to learn a kid what an algorithm is, go bake him an apple pie. There are 4 eggs that go into there. There's some milk. When I make this round turning things, then it's going up. It's being more stiff. And in the end, my outcome will be an apple pie. Or if I'm learning my kid what a sequence is, okay, we're going to do a sequence and it's getting dressed for school. So are we first starting with the pants and then the underwear? That will not really be the right way, right? So in that sense, most of the principles of coding you can already learn by your day-to-day jobs, your day-to-day games that you're doing with your kid. And then from the age of 7, you can introduce code as a game. Most of us will have seen Scratch, our lovely cat. It's brilliant for kids. It works very nicely. You can start at this, recommended from the age of 7. And it will go a little bit faster if they already know the principles that we just talked about. Then from the age of 12, on average, we recommend to start with text-based coding. So you can really try to still use gamification, but there are some platforms which can help you with this. For example, CodeKid. They make like Minecraft tutorials, so a kid can actually play Minecraft and write their own code and then see whatever they've written in code back in Minecraft. It's kind of cool, right? So yeah, that's kind of it.